Okay. I've been hanging with Eggy Cooper a lot. Now let's get— Huh? What the heck is this?
That of the screen, Lemmy. The screen is perfect to watch.
But that's not Iggy.
No. It's not.
Okay. So where is he? You know, Iggy Cooper? When I spend the most time with him.
He will be coming just about now.
Hi guys. I'm Iggy. Today, I'll be talking about the periodic table of the elements.
Iggy, what is the periodic table?
What is the periodic table, you might ask? That's a good question, Lemmy. Let me tell you, and for all of you, the periodic table is a table that consists all 118 elements. There are 10 categories on the periodic table. That's a lot of tiles to name them all of the elements. But what about the different types of categories of the periodic table? Well, I'll explain about these categories, also known as the lithium family, are founded in group 1 and comprises lithium, sodium, potassium, rubidium, cesium, and francium. Hydrogen is considered to be another non-metal and placed in the same group, is not an alkali metal. Alkali metals can be highly reactive, have one valence electron, have a charge of +1 and have the lowest ionization of energy in their respective periods. The alkaline earth metals, also known as the beryllium family, are founded in group 2 and includes beryllium, magnesium, calcium, strontium, barium, and radium. Alkaline earth metals have 2 valence electrons. The transition metals is the largest category of the periodic table, founded in groups 312 and consists scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium, lanthanum, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, gold, mercury, actinium, rutherfordium, dubnium, seaborgium, borium, hassium, meitnerium, darmstadtium, roentgenium, and copernicium. The icosagens, also known as the boron family, are founded in group 13 and consists boron, aluminium, gallium, indium, thallium, and nihonium. They have a charge of +3, and have 3 valence electrons. The crystallogens, also known as the carbon family, are founded in group 14 and consists carbon, silicon, germanium, tin, lead, and possibly fluorovium. They have a charge of -4, and have 4 valence electrons. The pinctogens, also known as the nitrogen family, are founded in group 15 and consists nitrogen, phosphorus, arsenic, antimony, bismuth, and moscovium. They have a charge of -3, and have 5 valence electrons. The chalcogens are also known as the oxygen family and can be founded in group 16 and consists oxygen, sulfur, selenium, tellurium, polonium, and possibly livermorium. They have a charge of -2, and have 6 valence electrons. The halogens, also known as the fluorine family, are founded in group 17 and includes fluorine, chlorine, bromine, iodine, astatine, and tennessine. They have a charge of -1. Halogen come from salt former, creating compounds. Halogens have 7 valence electrons. The noble gases, also known as aerogens or the neon family, are founded in group 18 and consists of helium, neon, argon, krypton, xenon, radon, and oganesson. The noble gases have a charge of 0. They have extremely low temperatures, have 8 valence electrons, and they can be stable. The lanthanides is comprised of 15 elements starting at 56 and ending at 71, including lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and lutetium. The lanthanide series make up the inner transition metals. All of the lanthanides have at least one stable isotope except for promethium. The reason for this placement has to do with the electron configurations of these elements. The actinides consists 15 elements starting at 89 and ends at 103, including actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium, and lawrencium. The actinide series also make up the inner transition metals like the lanthanides. All actinides are radioactive and release energy upon radioactive decay. The actinides are most known for the elements uranium and plutonium, which are used in nuclear reactors and nuclear bombs, but none of the actinides have a stable isotope. Like I said, the reason for this placement has to do with the electron configurations of these elements. How does the periodic table connect to science? The periodic table connects to science because most elements can be found in nature, but few elements can be observed in the laboratory. It's also because that the elements on the periodic table all have protons, neutrons, and electrons that help to determine the element's name. How is the elements on the periodic table is important? It was important because some elements have properties. Unlike oxygen is used for air, oxygen also acts as the lungs in our body. We all need oxygen to survive. Without oxygen, we could possibly die. Fluorine, used in toothpastes, helps to clean your teeth so it'll become whiter. Neon, being used in neon lights and neon signs, can help to glow in the dark. Magnesium, used for chlorophyll in plants, helps to make plants grow. Calcium, used in bones in our system and teeth, helps to grow strong. Krypton, used in light bulbs, can help to light up your room. And for hydrogen and helium being used in the sun gives us light to the whole planet, which plants and animals needs it. Does neutron count as an element? Possibly no, it's not an element. It's an particulate of a mass of 1, same as proton. It has no protons, nor electrons. The symbol for neutrons is lowercase n. The charge of a neutron is neutral, so it has no charge. All elements have neutrons, except hydrogen, because hydrogen has 0 neutrons. Element etymologies. What is an etymology? Etymology is the study of the origin of words in which had their meanings throughout history. Every element has etymologies, whether it's Greek, or any other language. By naming after a character or concept. Naming after a mineral or a substance that's similar. Naming after a place or a geographical region. Naming after a property of the element. Naming after a scientist. Some elements can be old and some elements can be new. Here's all of the elements that are discovered, and how they are named, and why did they used for 12 ancient elements. 9000 BC, copper. 7000 BC, lead. 6000 BC, gold. 5000 BC, silver and iron. 3750 BC, carbon. 3500 BC, tin. 3000 BC, antimony. 2500 BC, arsenic. 2000 BC, sulfur and mercury. 1000 BC, zinc. All of the elements that are ancient are known to humans. Only one element can be discovered in the 1600s. 1669, phosphorus. 21 elements are discovered in the 1700s. 1732, cobalt. 1735, platinum. 1751, nickel. 1753, bismuth. 1755, magnesium. 1766, hydrogen. 1771, oxygen. 1772, nitrogen and barium. 1774, chlorine and manganese. 1778, molybdenum. 1781, tungsten. 1782, tellurium. 1787, strontium. 1789, zirconium and uranium. 1791, titanium. 1794, yttrium. 1797, chromium. 1798, beryllium. 50 elements are discovered in the 1800s. 1801, vanadium. 1802, tantalum. 1803, palladium, cerium, osmium, and iridium. 1804, rhodium. 1807, sodium and potassium. 1808, boron and calcium. 1810, fluorine. 1811, iodine. 1817, lithium, selenium, and cadmium. 1824, silicon. 1825, aluminium and bromine. 1829, thorium. 1838, lanthanum. 1842, terbium and erbium. 1844, ruthenium. 1860, cesium. 1861, rubidium and thallium. 1863, indium. 1868, helium. 1875, gallium. 1878, holmium. And ytterbium. 1879, scandium, samarium. And thulium. 1880, gadolinium. 1885, praseodymium. And neodymium. 1886, germanium. And dysprosium. 1894, argon. 1896, europium. 1898, neon, krypton, xenon, polonium, radon, and radium. 1899, actinium. 29 elements are discovered in the 1900s. 1906, lutetium. 1908, rhenium. 1911, hafnium. 1913, protactinium. 1937, technetium. 1939, francium. 1940, astatine, neptunium, and plutonium. 1942, promethium. 1944, americium and curium. 1949, berkelium. 1950, californium. 1952, einsteinium and fermium. 1955, mendelevium. 1958, nobelium. 1961, lawrencium. 1968, rutherfordium. 1970, dubnium. 1974, seaborgium. 1981, borium. 1982, meitnerium. 1984, hassium. 1994, darmstadtium and roentgenium. 1996, copernicium. 1999, fluorium. 5 elements are discovered in the 2000s. 2000, livermorium. 2002, ogneson. 2003, moscovium. 2004, nihonium. 2010, tennesin. There are more elements like ununenium, or ununbium, can be discovered in the future. In conclusion, the periodic table is a simple table that includes an atomic mass or number, a symbol, and the element's name, but you can tell by counting the protons. In fact, the periodic table wasn't that hard, and was related to chemistry, and/or science.
Awesome
That's
presentation.
Yeah, great presenter. 9 out of 10.
Thank you for listening to the periodic table information. And Lemmy and Ludwig, thank you for liking this.
No
You're
problem.
welcome.
But all of yours is true.
Yep, all of the information about the periodic table is true.
Oh, good
okay.
point.
Guys, if you liked the video, click the like button. Also, click subscribe to Jacob Harrington's channel. If you have additional information about this, comment below.